You've heard the arguments, right? Flat Earth versus globe Earth. It's a debate that gets a lot of attention. But what if that whole thing, the entire argument, is just a distraction? Today, we're diving into a really provocative idea that claims both sides are missing a much, much bigger mystery. So yeah, let's get into it. And this quote right here is the core idea from the source we're looking at. The argument is that it doesn't matter which side you're on, you're still not even close to the real questions. The actual truth from this point of view is something that's not even on the table. So how does the speaker even begin to build a case like this? Well, we're going to break it down into three key parts. First, we'll look at the supposed limits of what we can physically observe. Then we'll get into a critique of mathematics itself. And finally, we'll take a wild journey through cosmic scale that, honestly, puts everything into a totally new perspective. All right, so the first pillar of this whole argument is built on a pretty fascinating contradiction. It's all about the smallest size that science says could exist versus the smallest size our absolute best technology can actually see. First things first, let's talk about the theoretical bottom limit. It's called the Planck length, and in theory, it's the absolute smallest measurement possible. You can kind of think of it like a pixel of the universe. You just can't get any smaller than that. And just to give you a sense of this number, that's a decimal point followed by 34 zeros and then a 1. It is an impossibly, almost ridiculously tiny scale. It's the theoretical floor of reality itself. But, and here's the twist, the speaker brings in this quote, which he attributes to physicist Dr. James Gates Jr., and it claims there's a hard physical limit to what our current technology can actually measure. And that limit is 10 to the minus 18 meters. Now, that is still unbelievably tiny, but, and this is the whole point, it's a mind-boggling 100 quadrillion times bigger than that theoretical Planck length. And this is where the argument really starts to take shape. You've got this massive, massive gap between the theoretical smallest thing and the smallest thing we can actually observe. According to the speaker, this implies there's this huge, unseeable reality that we just can't get to with our tools. And that leads to the speaker's big challenge for mainstream science. It's a pretty good question, actually. How can we say we can see stars that are millions of light years away, which from here would seem way smaller than our tech limit, if we can't even measure things at that scale right here on Earth? So if our eyes and our tech can't see these things directly, how do we know about them? Well, the answer is math, right? But the next part of this argument is that the very tool we're using, mathematics, is, in the speaker's view, fundamentally flawed. And for his big example, he picks pi. You know, we all learn it as 3.14, but the reality is that it's an infinitely long number that never repeats. So every single calculation we do, even with the world's most powerful supercomputers, has to cut it off somewhere. It's always an approximation. And this is the rhetorical challenge he throws out there. If we literally can't use the full true value of a number as basic as pi in any calculation, can we really call the result of that calculation truly exact or finite? So this right here summarizes his whole critique. If our math is built on a foundation of approximations, of rounding things off, then how can we really trust the grand cosmic conclusions that we build on top of that math? This whole takedown of our scientific tools brings us to what is really the visual centerpiece of the whole argument, a journey through the scales of the universe, designed to show just how tiny and insignificant our little worldly debates really are. All right, let's take this trip. We start at the theoretical bottom, the Planck length. Then we zoom past the limit of our technology, past something we can actually see, like a grain of sand, past our own human scale, and we keep going, way out, past the edge of our solar system, all the way out to the staggering scale of the Virgo supercluster. And from way out here, the Earth is just gone. The solar system, gone. Our entire galaxy, the Milky Way, becomes just one tiny little point of light among billions of others. Every reference point we have just completely evaporates. And this gets us right to the speaker's ultimate point. Arguing about the exact shape of our tiny little home is totally meaningless when we have lost all context of where that home even is in the unimaginable vastness of everything. So this feeling of being completely and utterly lost in space, it leads directly into his final conclusion. If this whole flat Earth versus globe Earth thing is just a distraction, then the big question is, what is it distracting us from? He puts it like this. Why would anyone go to the trouble of maintaining a lie of this size for centuries? It must be protecting a secret that is way more important, and maybe even way more dangerous than just the shape of our world. And then he starts pointing to what he calls clues, things hidden in plain sight. He mentions the DARPA logo, describing it as an ellipsoid, not a perfect sphere. He talks about Antarctica being the most heavily guarded place on the planet. And then he suggests that maybe, just maybe, the secret they're hiding isn't even on this planet. And this really is the final takeaway from the source material. The point isn't to convince you the Earth is flat or that it's a globe. The point is to argue that getting an answer to that question isn't the real prize. The real prize is figuring out what the right question is in the first place. And so, we end this explainer right where the speaker leaves his audience, with a question that's designed to make you rethink the whole search for truth. If this entire debate is a sideshow, he asks, what's the main event? What is it that we should really be looking for?